Welcome back. We were discussing in Fundamental of Electronics the diode circuits. We have covered the filters and IC voltage regulators. In this lecture, let us see the discussions on clippers and limiters. When we talk about the rectifier diodes, they are basically used in low frequency power supplies, generally optimized for 50 to 60 Hz frequency, and the power rating anything above 0.5 watt. The forward current rating are usually measured in amperes and it is limited in use outside any power supplies. So generally rectifier diodes are used for power supplies for low frequency and power rating should be 0.5 watt. When we compare the small signal diodes, they are generally used for high frequencies. The power rating lies between less than 0.5 watt and the current rating here is measured in milliamperes, whereas the rectifier diodes are in amperes. Hence, it is used for smaller and lighter construction for the small signal diodes. We will see the clipper circuit and we will first see the positive clipper and then move to negative clipper. So what is the meaning of clipper? And in the positive sense, it removes the positive part of the waveform. So negative clipper will remove the negative part and positive clipper will remove the positive part. It is generally useful for small signal shaping, the protection of the circuits and in the communication circuits. This is the circuit for positive clipper. You can see there is a source which is AC source. The internal source resistance is there. You have a load connected on the output side and there is a diode which is connected which acts as the positive clipper circuit. So the positive part of the input waveform is not present in the circuit and only the negative part will be there in the output waveform. So when we give the positive half cycle, the diode will conduct because it is forward biased and the output voltage will be 0 volt. Practically it is 0.7 volt because you have certain threshold forward bias voltage. When we talk about the negative half cycle for the input voltage, the diode is open, this is reverse biased and the negative half cycle appears across the output. So all the negative output we are getting it. So we can say that the positive clipper is removing the positive part of the waveform, keeping the negative part. There is a small series resistor that is connected smaller than the load resistor in the circuit. The output peak, if we see for this circuit, is basically we will get 2 times the secondary voltage peak. The diode voltage will be conducting and the forward voltage of 0.7 volt. And the clipping level will be 0.7 volt and not 0. So this voltage, whatever we have small amount, is because of the forward voltage drop. So if you take the example of 20 volt as the input signal peak, which results in the output. So here we get minus 20 volt in the negative half cycle. Let us see the negative clipper now. So negative clipper circuit will be having reverse diode polarity. So the diode, you can see we have reversed it in the circuit. So it will remove the negative part of the signal. So now you do not have the negative part of the signal in the output. Output waveform ideally has only the positive half cycle. So we have only the positive half cycle in the output. And if the clipping is imperfect, this may be due to diode offset voltage, which is the barrier potential. So if you have the diode offset voltage or you basically give this offset voltage, which is the barrier potential, then the clipping will be imperfect. So the clipping level now in this case can be 20.7 volt, taking this as example. If the input signal is 20 volt, output signal will be shown as given here. So there is no negative peak, only the positive cycles are passing. What is diode clamp or otherwise the limiter? We can see that 2 diodes are there which are connected back to back. And in the normal operation, if the input voltage peak is 15 millivolt, if you take the example, then the output will be same signal if the diode is off. And these diode clamp circuit are generally used for sensitive part of the circuit. So the purpose, if we talk about the diode clamp circuit, it is used for protection. It limits the input signal to protect the sensitive circuit. So when you have the sensitive circuit, then the diode clamp will be protecting this sensitive circuit from high voltages. Like if you talk about the positive negative limiter, because we are using 2 diodes. So if it limits the output 0.7 volt, if the input exceed 0.7 volt. So when the input voltage will exceed 0.7 volt, then it will limit it. Similarly, if the output is less than 0.7 volt, then the input will drop to below minus 0.7 volt. So anything above 0.7 volt and below minus 0.7 volt, the circuit will be protected. If we talk about the examples of some sensitive circuits, one, we have the operational amplifiers where the normal input should be less than 15 millivolt and the voltage should be greater than 0.7 volt under abnormal condition. So limiter prevents excessive voltage. So no excessive voltage will pass. Other example, we can take moving coil meter where limiter protects against any type of excessive voltage or the current. So diode clamp circuit, then we have clamps or limit the voltage to a specified range, the lower limit and the higher limit. And operation, this diode conduct only during the abnormal conditions. So when the abnormal conditions will be there, when the signal is too large, then only the diode will come into picture in its operation. What is biased clippers? So we see the positive bias clipper and the negative bias clipper. So these are basically using the positive clipping. Ideally, we take 0 volt, but you have certain threshold voltage of 0.7 volt. So it changed the reference level because you are providing some bias, so the reference level will change. So certain external voltage we apply in the circuit. You can see here we are applying certain external voltage to the diode which was already connected in the previous case. So if you have the positive biased clipper, you add a DC voltage source in series with the diode. So here we have added a DC voltage in series with the diode, and the now new reference voltage must be less than the peak voltage. And ideal diode will conduct starts when the input voltage is greater than this B. So whatever the offset we have given, if the input voltage is greater than that, the diode will conduct. But this is for ideal condition. When we talk about the second approximation, then we have to add 0.7 volt because this is the threshold voltage. So that will be conducting only when the input is greater than the supply voltage, that is the DC offset voltage plus this threshold voltage, 0.7 volt. When we talk about the negative biased clipper, you can see here we have connected one DC voltage source which is connected in series with the battery, but it is reverse diode and the battery we have. The diode is also reverse biased. So we have changed the direction of the diode. The reference level now changes from to minus V minus 0.7 volt. So it is basically minus of V plus 0.7 volt. So we have changed the reference level and the output waveform negatively clipped at the bias level. So here you can see that if the input is AC cycle, then what we have, the negative cycle is passing and the positive is clipped to now new reference level which is V plus 0.7, and in this case the positive is passed and the negative is clipped at minus V minus 0.7. Now we can combine also this clipper circuit. So if we have the diode and the positive DC voltage and another diode which is reverse connected with the negative DC voltage, that too we can connect it together. Then in that case the diode D1 will clip the positive part above the positive bias level and the diode D2 will clip the negative part below the negative bias level. So both positive and negative will be now offset and clipped. When input voltage is much larger than the bias level, then you get the output signal in the form of a square wave. And here the signal shaping, the clippers enable shaping signals into specific waveform. So whatever the time or shape of the waveform you required when the input is sinusoidal, then you can use such type of connections where you have bias clippers combining the diode and the DC source. If you want to clip the circuit without using the battery, then in that case you can use multiple diode connection. So when you use silicon diode, each diode will have the biasing of 0.7 volt. And if you are using 3 diodes, then the clipping level is multiplied with 3, that is 2.1 volt. And that acts as a diode clamp or limiting to protect any type of sensitive circuit. Now here you can see in this circuit we are using a voltage divider. So there are 2 resistances R1 and R2. So here resistance R1 and R2. This is giving you a bias voltage which is in accordance with the voltage division rule. We are getting R2 by R1 plus R2 into the DC voltage supply whatever we are giving. So output will be clipped when this input voltage whatever we are giving is greater than the bias voltage plus 0.7 volt. So 0.7 volt again is coming from the threshold voltage, and the bias voltage we are computing by voltage division rule. So bias diode clamp, if the bias level set to plus 5 volt. So here we can see that there is a diode clamp circuit where it is protecting above 5.7 volts. So 5 volt source we are connecting in the diode conditions. So it protect again large input voltage, example like suppose 100 volt. So output is limited to plus 5.7 volt. If we want to remove the offset, then there is a variation where the diode D2 which is connected and provide the bias into slight forward conduction zone. This puts the diode D1 which is connected here on the verge of conduction. So the result is diode D1 will conduct near 0 volt. So there will be no offset and it will minimize the offset and conduction will be at 0 volt. So diode D2 has now biased D1 to remove any type of offset voltage. So these are the different types of diode circuits which changes the bias level and changes the shape of the waveform whatever we require. So we will see in the coming lectures some more discussions on diode circuits. Thank you for now.